Good day. In this lecture, we go to chapter 4, functions, and these are not tested. 4.1, some elementary mathematical functions. Matlab as well as TIFF have built-in functions. For example, we have seen this before: exponential, square root. Log by itself is natural logarithm. Log 10 is for log base 10. ABS returns the absolute value. In other words, a negative number is written as a positive number. Angle will return for complex number x the angle for that complex number. Of course, it will return the angle in radians. This is just complex conjugate of x. Imac is the imaginary part of x. Real is the real part of complex number x. Some numeric functions. Ceil is rounding off to nearest integer towards infinity. Fix towards 0. Floor towards minus infinity. Round is just normal rounding off. So round 2.9, you get 3. Round 2.4, you get 2. Sign will just return 1 if x is positive, 0 if x is 0, minus 1 if x is negative. So here we have vector y. So the operation here is going to be element by element basis. Sitting minus 2.3. Minus 2.3 is between minus 2 and minus 3. It's toward plus infinity. So the rounding off is going to be the upper value, which is minus 2. Because minus 3 is lower. Fix is towards 0. Floor is towards minus infinity. Normal is just normal rounding off. To minus 2.3 becomes minus 2. 2.6 you get 3. 3.9 you get 4. ABS is just the absolute value. Only this will be written as positive because the rest of the numbers are already positive. Trigonometric functions. Sine, cosine, tangent. The angle here are in radians. If the angle are in degrees, you have to put d at the end. Inverse trigonometric functions. Arc, sine, arc, cosine, arc, tangent. This will return angle in radians. To get the angle in degrees, you have to put d at the end. 4.2 user-defined functions. Just like C programming, we can write our own function in Matlab. The syntax is keyword function. In square bracket, list of all output variables. Function name. In simple bracket, list of all input variables. For example here, create a function named cylinder to calculate volume and surface area of an closed-ended cylinder of radius r and height h. So basically, you just type this in the editor window. Saving some time, I just copy paste, Ctrl C, TIFF compiler, editor, Ctrl V. So file, save as. So I'm going to save at this location. File name is going to be the function name, cylinder. Extension is .m. Of course, you can search where you want to folder, location where you want to save the file to. Here, I'm saving at this location, in this folder, so save. To use the function, I go to the command window. So the function is already here, cylinder.m. So I just call this function. R value and H value. The function, remember, has two outputs, volume and surface area. If you use it in this form, it will only return one output, the first one, volume. To get all output, you must use this form of calling the function. Let's say volume, surface area. Then I'll get the volume and surface area. You can use any variable name, but the return value will follow the list of the outputs in the original function. So in the editor window here, I go to the function cylinder. Here we have the dot element by element operator. Why? Because instead of single R and H, I can do calculation for multiple values of R and H. Of course, for each pair of R and H. For example, R is going to be 2, 3, 8. H is 1, 4, 1, 2, 7. Has to be the same size because the calculation will be for each pair. R1, H1, R2, H2, R3, H3. So the calculation is going to be for this vector. So again, for each pair, R and H, a pair of values for volume and surface area. R3, H3, this is going to be volume 3 and also surface area 3. In Matlab and OTIF, there are many functions, useful functions. I'm going to show just one, the F0 function. This function can be used to find the zero of a function, fx. The keyword is F0. Inside the bracket, we have the function handle. The second value is the user supplied guess or estimate where of x, where f is going to be 0. Let's say there are two. I'm going to show two methods. The first one is going to be by creating a user-defined function that solve y equal to this value, this x plus 2 minus x minus 3 equal to 0. So we want to solve what's the value of x. First, create the function, this function. Saving some time, Control C. Clear the screen. Go to the editor window. Delete this. Control V. So I'm going to File, save file as. Of course, I'm going to save in this folder. The name is going to be the function name, F1. Extension is automatic.m. Save. So this function has one output, the y value, and a single input, the x value. So to use this function, I just go to the command window. This is the function F1. Just type F1, any value of x. There is a danger if you just copy paste because sometimes there are hidden fonts or characters that you do not see. It's better to just type fresh here rather than copy paste. See? So for this function, x is equal to 2, it returns f value. So we can use f0 to find the value of x where f is going to be 0. But it's a good idea to plot y versus x to find the approximate value first. To do this, just a simple plotting. Go to the command window. Let's say x is between -1, increment of 0.1 up to 3. Our y values. y function equal to x plus 2 times exp minus x. It's going to be minus 3. So here we have a vector x from minus 1 to 3, increment of plus 1, plus 0.1, and for each value of x, we're going to have the y values. If you want to see the xy values, let's say I want to create a table, just tap. These are row vectors. I want to display in the column format of column vectors. So it's going to be x transpose, next to it y transpose. So remember our x values from minus 1 to 3. And for each value of x here, we calculate here in this vector the value of y. So I just plot sy. It's a black solid line. So detail on this is going to be in next chapter, plotting. Black colored solid line. So this is our function between minus 1 and 3. So here is the y equal to 0. So there are two values of x, where y is 0, one here, the other one is here. So we know it's in between this interval, the other one between this interval. If you want to copy this figure, this figure, you just need to hit the control print screen, control key and the print screen key, it will copy this figure. Delete that. So I know there are two solutions. So we can call this function f1 using the f0. Remember f0? So this is a function handle, which is basically the f1 file just now, the function. So the first solution, I'm calling it s1. It's going to be f0 function handle. Remember our function f1, comma. So the first solution is near somewhere between minus 0.5. So that's the solution. The second solution is going to be near somewhere near let's say 2.5. It's between 2 and 3. To check for the solutions, you can substitute these two values. I should have called this S2. For example, calling the function f1, putting in s1, this s1. So I get a 0. The first value. This is basically 0. So this confirms our solution. These are basically our initial guess. And you're going to learn this basically in detail in applied numerical methods in third year. You're going to learn all these methods. Method number 2. Here we can use the command window. There is no M file involved. It's known as anonymous functions. Syntax this function handle, this symbol, argument list, and expression. Argument list is a comma separated list of all input arguments to be passed to the function. And expression is any single valid Matlab expression. Back to our previous example. I'm going to call it f2. This is my anonymous function. It's a function of x. It's going to be x plus 2 exp minus x minus 3. This is not safe here. It's just inside the command window. For the first estimate, S1, I'm going to call this F0. Just the function handle. There is no, the symbol is not here. 2, somewhere between 0, minus 1 and 0. Let's say minus 0.5. So I have the first solution. Second solution, somewhere near between 2 and 3. Let's say 2.7. Second solution. Of course, to check for the solution, F1, S1, F2, X2, F1, X2, completely 0. If you use the first method, you must put this alias sign here in the function handle. If you use the second method, anonymous function, there is no, this symbol is not, there's no such symbol in front of the function handle. So that's the end of chapter 4. These are not tested. In the next lecture, the final lecture is going to be chapter 5, plotting. So plotting, you require plotting for your project too. Thank you.